Hello. Hello, Mr. Eric. Hello, Mr. Ryan.
Hello, Mr.
So remember we talked about this merge the two sorted list, yeah? Yeah? Sorted linked list.
Build BST.
Yeah, I know. I left yesterday, but we talked about this merge two linked list, sorted linked list, like 1, 2, 4, and then it's 2, 3, 5.
7,
Remember?
9.
Yeah, you want to merge these two are sorted linked list or list. You know, if it's the list, it's the same algorithm. Okay. So look, we have a dummy head. This is dummy head. So what we do here?
Dummy head.
Dummy is we don't use it for the moment.
Dummy.
And points like okay. So now we have 2 pointers. Is 1 smaller than 2? Yes. So I take this, put it here. Okay. Now is 2 smaller than 2? It doesn't matter. So I link 2. So I can take this. 2. Is 2 smaller than 3? Yes. So I take this here and put it here. Yeah. Okay. Is 3 than 4 smaller than 4? Yes. So I put a 3 here and I take it off. Is 4 smaller than 5?
Yes.
I put a 4 here.
Then pop.
Then I need to get the remainder. Yeah. 5. Okay. So now this line is a sorted linked list. Yes. Okay. Got it? Yes. The complexity.
1. No.
Don't tell me 1 every time. Okay. Why you always say?
What's the numbers?
Okay, O M plus N, right? If M is the sorted linked list, the number of the nodes.
M is the linked list.
The number of linked list for one sorted is sorted. The number of nodes in the first linked list. The N is the number of nodes in the second linked list. Yes.
Yeah.
Okay, so let's O M M. Or if we can. O N plus N, or we can call it O N if N is the number of the linked list in the final sorted one. Okay, sorted version, yeah? Yeah? Okay, so now how about if we have K sorted list? If we have K, look.
No, I mean N.
So how, yeah, look, if we have K, how can we do it? If we have one line, can we do it? How can we do it?
How can we?
Look, we can
3 pointers.
we can merge it one by one, right? Yeah?
Yeah.
So let's define merge K list. And let's do it list. Here is list, okay? And then we can do this. The answer. The first answer is, let's do it. First answer is, okay. So now look, if length of the list is 0, then we return nothing, right?
Right.
Yeah, return the list or nothing. It depends on what you want to return. Okay. Then now we can say this answer equals list 0, the first linked list, yes? And then for I in range 1, start from 1 to length list.
And column.
Yeah, and then we can say answer equals merge answer list I, right? Yeah, we are actually merging this one by one. Yeah, and then return what?
Return merge no answer.
Yeah, return the answer. Yeah. So basically we have a list of linked lists. Yeah, we have a list of linked lists, and then we take the first one, we merge it to the second one, and we keep merging until all of it. Yeah. What's the complexity?
O-N. O-N and N.
This is O-N, okay?
A merge.
And there are K lists. How many are it?
K add N.
Add or multiply?
Multiply N.
Yeah, because we have a K list, and merging each one.
Multiply.
Yeah, merging each one takes N. So
Yeah.
complexity is okay, and okay. So can we do it similar way? Like how about if look if these are if the K list, yeah, if the K list look like if they are list like this, if there are 4, okay, 4 linked list. Let's say 4 linked list, okay. for linked list. Can we merge, divide and conquer?
They look like lollipops.
Look, can we merge these 4, divide it into half? Merge these 4 and merge these 4, yeah?
Yeah.
And for this 4, I can merge this 4, 2 and merge these 2. Until we know it's number of 2, then we can merge it. Do you get it?
Mm.
So we divide it into half. And then every time we merge, keep merging until it's smaller one. Until we know. Okay, so how can we do this? Look, if len, let's do this. Len equals length list. That's the number of list. Yeah, number of lists we want to merge. Okay. Okay, you tell me. If L is 0, return what?
None.
Now, write down.
No.
If L is 1, return what?
Return.
If it's there's just a list, we return what? We
One.
return itself, right?
Yeah.
Return list 1 because this returns a list, not a so list 1. How can we get the first element? Ryan, bracket, what number put here?
1.
0. It starts from 0. Okay. If length equals 2, return what? We have only 2 lists, 2 linked lists. We can just merge it, yeah?
Yeah.
Merge. Remember, we have this merge function, yeah? So what should I put here? List what?
List.
0 and list. What's the next one? What should I put? What number? 1, yeah. Because the first list and the second list way down. Okay, now the 3. Now the middle one. Where's the middle? Mid equals what? L what? Divided by what? The mid, roughly the mid.
What's L?
L is the length of
Divided
list.
by 2?
Yes, divided by 2, okay? So now we know the middle one. So the left, let's say left, okay? Left equal merge K list. We are calling it cell, yeah? Then now list up to mid, yeah? Remember yesterday we convert a sorted list into a binary search tree. We use list notation as well. A mid, yeah, up to mid, but not including, right? And then right, and we want to merge another half. Merge K list. List mid and column, yeah. So that basically you know the mid here, yeah. This is the mid, yeah. And you want to merge this, calling itself to merge this half, and calling itself to merge this half. That's what it does, right and right. And then we have the left here, and we have the right here. So what should we do now? The last sentence, return what?
Return right.
No, we have left, right.
List.
We have the left.
Then left.
Keep guessing. Left and right. So what do we do now?
That
We
list.
have 2 lists, and then we have merged the left
No,
part.
left plus right.
Merge, yes.
Left. Big brain.
And what?
Left. Left and right.
Yeah, well done.
See?
Yeah, you see? It makes sense, yeah? Yeah? So because we're dividing into two lists, and then we're calling itself to deal with a smaller problem, right? Until the length is 0, 1, or 2, then we know how to deal with it. And after we get this left and right linked list, then how can we merge it? We know how we can merge it. The complexity. Kn. It's still Kn. Why is it still Kn? Because it also needs the K times. Look. If like I have 1, 2, 3, 4, 5, 6. Let's say I want to merge. How many times I need to merge? Look, I tell you. Look, maybe 7, 8. Okay. Now the A list. How many times we want to merge?
3.
1 time, 2 times, 3 times, 4 times. Yeah. 5 times, 6 times, 7 times. You see? It's actually K minus 1 time. Do you get it? Yeah, even we divide it into 2, but still we need to merge these ones, yeah? Merge these ones, yeah? And merge these 2 ones. Merge this one, merge this one, merge this one, and then merge it once, and until we get the list, yeah? So it's still, even it looks like you divide into 2, But still, you need k times, k minus 1 time. But we drop the constant, so it's OKN. Yeah? Got it? Yes?
Yeah.
Why is that? Because we need to merge the k list. It's not like divide. It's not like the log and binary search. When we divide into half, we don't need to consider the other half, right? Yes? We take a number and always we divide into half. In that case, the complexity is what? Yeah, well done. Okay, do you make sense? Yeah, does it make sense? Yeah. So today, can you sum up what have you learned today? Just one sentence, and then the people in the world know. Okay, can you tell everybody?
We learned about merge k list.
K sorted list, yes?
Yeah.
And,
Yes.
And what else? Right, Eric, can you tell people what have you learned today?
Merge sorted list.
How many sorted lists? What's the function name?
This bit.
Yeah, merge k sorted list. List has to be merged. Yeah, we learn the merge to sorted list, and we apply this technique to merge k sorted list. What's the complexity?
OKN.
OKN. Okay, come on, OKN. Okay, that's it for today.
OKN.
OKN.